So today we're going to look at lesson 7-5. We are going to solve exponential and logarithmic equations. So for this first part, first of all, an exponential equation is always in the form of y equals b to the cx. Now this exponent just has to have a variable in it for it to be an exponential equation. And oftentimes this exponent could be an expression like 2x plus 5 could all be in the exponent. So it may not be as simple as this. So here's our example question right here. 5 to the 2x equals 37. And we're going to write the steps to solve. So theoretically, this first step is our given, if you recall that all the way back to geometry. So if you look from here to here, the only thing that changed, you got the 5 to the 2x here and the 37 here. The only thing that changed is you took the log of both sides. So you can actually take the log of both sides to help you get this variable out of the exponent. So there's a reason there. All right, then from here to here, you can see that from here, we have taken the 2x and looped it out in front. So we are expanding the left side. So expand any logs. Then from here to here, you can see that we have the 2x, but then we divided this side by log of 5 and this side by log of 5. So now when you look from here to here, all we've done is put this in your calculator exactly as you see it. It really is the change of base formula. And you're going to get this approximation in your calculator. So you're just going to use your calculator to divide that change in base. So use calc to divide. Then to go from here to here, we must have divided both sides by 2 to get our answer. Now let's be honest, there is actually an easier way to solve this equation right here than going through all of this. And so I'm just going to be honest with you, I rarely ever take the log of both sides unless I have to. Sometimes I have to, but more than often it's just so much easier to take this exponential form and convert it into its log form. So for instance, couldn't an alternative method be alternative method? That's an E, method. So I'm going to take this right here and I'm going to convert it to its log form. So it would be log base 5 of 37 equals 2x. Then couldn't I put this in my calculator as a change of base? It would look like this right here. And then to solve for x, wouldn't I divide by 2? So this would only take me 3 steps to solve. They took 5. So you were going to see me doing it this way most of the time because I quite frankly find that's easier and you're going to get the same answer. Okay, so then what are we going to do when we have a log in an equation? So here is an example of an equation with a log in it. So this one just happens to have 1 log, not 2 or 3. We'll talk about when you get that. But for our first step, of course, we have a given. Then from here to here, didn't we put it into exponential form? There's your base, and we switch these two. You can only do this if you have 1 log. And then from here to here, we just calculated what 3 to the 5th was and switched the left and right side. So calculate. And that's it. So let's look at some problems. And that's crooked. Still a little crooked. Much better. Okay, so for these first couple, you should already know how to solve them because we've solved these before. So in this particular case, you could take the log of both sides, but why? You've got a base of 5 here. Can't you turn 125 into a base of 5? If I can get like bases, then I can just set their exponents equal to each other. So let's do that. So the 125 becomes 5 to the third. And if that's the case, then their exponents must be equal, and there's nothing to solve. Now you are going to have to look for restrictions, but anytime our variable is in the exponent, your exponent can be positive, negative, or 0. So there's really no restrictions on our value here. So I would like you to try this one on your own. I realize that you can't turn 81 into a base of 21 or 27 or a base of 27 into 81, but you can turn them both into a same base. So pause the video, figure out what that is, and then restart it and check your answer. Okay, so I can take this 27 and I can prime factor it, and I get, whoops, not 2, that would be very wrong. I get 3 to the third power. And then that's 27 is raised to the 3x power equals 81 right here is going to be 3 to the fourth power. So then don't forget that we have to do power to a power and multiply that. So 3 to the 3x, or 3 to the, 3 times 3x is equal to 9x, and 3 to the fourth. So now you can drop your bases and just set your exponents equal to each other. Divide by 9, and you get 4/9. Because my variable was in the exponent, there's no restrictions on my answer. For these next few examples, you cannot do what we did in example 1. So I cannot take 17 and make it into a base of 3. You are going to need to use your calculator for this one. So this would not be on a non-calc portion of the test. So if we have exponential form, one of the easiest ways is to convert it into log form. So if I convert it into log form, I get log base of 3, and I switch the 17 and the x. So to find my value for x, I'm going to use the change of base formula. Log of 17 divided by log of 3. And so x is going to be, I'm going to round to 2 places. So I get about 2.58. And again, my variable's in the exponent, so there's no restrictions on that. So then I would like you to do, oops, here's B, sorry. I would like you to do B and C on your own, so pause the video and try those. All right, so for this one, to convert it to log form, I get log base 5 of 135 equals 2x. So 2x is equal to log of 135 divided by log of 5. And then I am going to divide both sides by 2 and divide this side by 2. And I actually can put this in the calculator exactly as you see it. Oops. Which is what I'm going to do. And I get approximately 1.52. Since my variable's in the numerator, there's no restrictions on it. Go to C. So for C, we're going to convert it into log form. So log of base 8 of 26 is equal to y minus 3. So y minus 3 is equal to log of 26 divided by log of 8. And then if I want to get y by itself, I'd have to add 3. And so y is going to approximately equal, and of course this is going to go on my calculator using those parentheses exactly as I see it. So we get approximately 4.57. And again, my variable's in an exponent, so there are no restrictions. All right, so if you want to look through this one, feel free. Let me see if I can make this a little bit smaller. I'm going to show you the graphs here in my notes. I don't require you to know how to solve this by graphing or by the table at all, because you can solve it the way we did it up here. But if you want to, here's the directions here. Again, I find it just as easy, if not easier, than what these are here by taking this and converting it to log form. So log base 2 of 9 is equal to 3x, and then we would divide this side by 3 and divide all of that by 3. And so you can just simply put it in your calculator. That's a whole lot less work than solving by graphing or by a table. But if you like that, you can explore that on your own. All right, so let's look at this word problem. I'm going to make it just a smidge bigger. Okay. So the world's population can be modeled by the equation right here. So you can tell that this is a growth equation because it's in that growth exponential form where this is your growth, this is your growth percent right here, this 0.014, which converts to 1.4% of growth. This would be our original amount, 6.72. And then we're going to let P be population, so this is calculating population in billions of people, so that's important in billions. X years after year 2000, so that's also important that it's X years after the year 2000. So the year 2000 should be year 0. And we're going to use the model to find A, the population in 2013, and B, the year when the world population is about 9 billion people. So A is easier than B. So if we're to find the population in 2013, then that needs to be, well, where are you going to put that? So 2013 is time, so that's X. And it's the number of years after 2000. So that means that X is equal to 13. So we're going to take that equation. P is equal to 6.72 times 1.014, and instead of to the x, we're going to raise it to the 13th power. So put that in your calculator exactly as you see it. And we get approximately 8.05. You need to ask yourself, is a decimal appropriate in this situation? And since P is population and it's in billions, 8.05 billion seems reasonable. So answer the question. Therefore, the population will be about or approximately. You have to use a word of approximation because we rounded it. So the population will be about 8.05 billion in 2013. Okay, so then B is a little bit more of a difficult situation because it says the year you are to find, the year when the world population is about 9 billion people. So instead of about, we're just going to say 9 billion. So that means that 9 billion is going to get replaced. So let me underline my 9 billion is going to get replaced for P. So P is going to equal 9. So in our formula, we're going to have 9 here equals 6.72 times 1.014 raised to the x. So in order to solve this, before we can even put this into log form, you have to have the exponent part, or the base in the exponent, that exponential model part by itself. So we have to divide out the 6.72. So I'm going to divide this side by 6.72 and this side by 6.72. So you get a very long fraction in your calculator. You get 1.339285714. You probably don't want to write all that on your paper, but you do want to leave that in your calculator. Never, ever, ever round in your calculator. Don't round till the very end. So I'm going to flip this equation around so I have my exponent side on the left. So I have 1.014 to the x equals, I'm going to round just on paper, 1.3393. Okay, and it keeps going, right? Keeps going. If I can get my dots in here. It doesn't want to give me dots. Okay, so then I want to put this into log form. So the log base 1.014 of this long number 1.3393 yada 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 is going to equal x. So to get x, we are going to use the change of base formula in our calculator. So this log divided by this log. So in order to get this whole big number in your calculator, you have that number stored in your calculator right now as your last answer. So all you have to do is put log, and then you're going to hit second negative, because remember above your negative sign on your calculator is ANS for answer. So log second answer, and then end your parentheses, and then divided by log 1.014, end your parentheses, and then enter, and you get approximately 21.0126. So what that means, and to alleviate any arguments about whether this is year 2021 or year 2022, if you were to put this part of the formula right here into your calculator, into the y equals, and you were to graph it, if you went to your table of values and put in 19 in for x, 20 in for x, 21 in for x, you're going to end up with some values that don't reach 9 billion. But as soon as and even if you put 21 in, you get 8.9 whatever. So it's close to 9 million, but it's not 9 million until you put 22 in, and then it spills over past 9 million. So the question is, what is the year when the world population is about 9 billion? It occurs somewhere between the year 2021 and 2022. So to alleviate any argument, we are going to write our answer as, therefore, the population about 9 billion between the years 2021 and 2022. You won't see the answers online saying that, but that's what I'm telling you to say. All right? All right, so let's finish up. Oops, that's a little crooked. Close enough for government work. Okay. So the last two examples we're going to go through. They get slightly more complicated, but it's really no different. You should have the tools to solve. So if you want to pause the calculator, do your own work, and then check, feel free. But I'm going to kind of zip through these. So because I have one log, I am going to put this in exponential form, so it's understood that we have a base of 10. So I have 10 to the 1/2 is equal to 2x plus 1. And then 10 to the 1/2 is the square root of 10 equals 2x plus 1. To solve for x, I'm going to subtract 1. And I'm going to flip the equation around. I have 2x is equal to the square root of 10 minus 1. And to solve for x, I'm going to divide all of this by 2. So you will need your calculator to get an exact answer. And so on here, the square root of 10 minus 1 and all of that divided by 2 is approximately, because I'm going to have to round, so I get squiggly equals, I'm going to round to 2 places, 1.08. Now, since we are solving logarithmic equations, you have to take your answer and plug it in here and make sure that this answer does not create a value that is 0 or negative. Because remember, when you're taking the log of this item here, it is understood as part of the parameters that it's got to be a positive number. So since this is within our parameters, we can accept 1.08 as a solution. So then for B, you have a couple of choices. You could loop this up and make this 3 minus 2x to the negative 1 and then convert it to exponential form, because you can't convert it right now with something in front of the log. Or you can divide both sides by a negative 1, because technically there's a negative 1 in front of here. And so that gives you log, and of course it's understood that it's a base of 10, of 3 minus 2x equals positive 1. Convert that to exponential form, you get 10 to the 1 is equal to 3 minus 2x. 10 to the 1 is 10, equals 3 minus 2x. And then we are going to subtract 3 from both sides, and I'm going to flip the equation around because I want my variable on the left. So negative 2x is equal to 7. Divide by negative 2, and I get x is equal to negative 2/7. Just because your answer is negative doesn't mean you're going to throw it out, but you got to take this value and plug it in up here. So I'm going to kind of do that off to the side. So 3 minus 2, I'm going to put over 1 and multiply it times negative 7 over 2. So the two negatives make a positive, and then the 2's cancel. So you end up with 3 plus 7, which is 10. So this value is going to give us a positive value in here, so I can accept it as a good solution. Wasn't there a C? I felt like there was a C on there. Nope. Okay, so let's go on to the last page. All right, so for this one, that's a little crooked, just a smidge. Okay. I guess it still is crooked. That would super bother me. All right, here we go. Okay, so this time for this last example, we have a little bit different situation. We still have logs in here, but we've got 2 logs, and we cannot convert this into exponential form until we get rid of both logs. So that's one reason why we learned how to condense logs. It's also the reason why we learned how to expand logs for some of the previous ones. So if I have 2 logs that are being added, I can compress them by multiplying them. So log, and I'm going to put the x first, of x times x plus 9 is equal to 1. So again, these are being added, so I just multiplied them. Then I want you to recall that this is a base of 10, it's understood. So to put this in exponential form, I have 10 to the first is equal to x times x plus 9. So 10 to the first is 10. Distribute your x, so x times x is x squared, and x times 9 is 9x. I need one side equal to 0, so I'm going to subtract 10. I get 0 equals x squared plus 9x minus 10, and then I want to factor. X squared becomes x and x. What factors of 10 subtract to give you 9? That would be 10 and 1. 10 is bigger, so it gets the sign of the middle term. 1 will have to be negative. If you set x plus 10 equal to 0 and x minus 1 equal to 0, you will get x is equal to negative 10 or x is equal to 1. We have to go and take this and check it into both of these. So if I put negative 10 up here, negative 10 plus 9 gives you negative 1. It is not going to work here. We cannot take the log of negative 1. Try putting that into your calculator, you're going to get an error message. Same thing here, if I put negative 10 here, you cannot take the log of a negative number. So it's going to give you an error message there as well. So we are going to cancel out x equals negative 10. Even though this is positive, you still have to check it, because if this were x minus 9 and you put a 1 here, 1 minus 9 is negative 8. It won't work. But fortunately, it's a plus. So 1 plus 9 is 10. That works. And a positive 1, that works. So that is a good solution. So pause the video and try this one on your own. Okay, so let's go ahead and compress our log. So because we're subtracting, I am going to divide those two logs. So because of the subtraction, I'm dividing this by this. And if I were you, I'd reduce this. So 6 divided by 3 is 2. So you get log of 2 over x is equal to negative 2. It is understood you have a base of 10, so 10 to the negative 2 is equal to 2 over x. Since I have a fraction on the right, it would be in your benefit to convert 10 to the negative 2 to its fraction form, which is 1 over 100 equals 2 over x. Cross multiply and solve. You are going to get x equals 200. Check your solutions to see if it will work. This is the only place where there's a variable. 3 times 200 is 600. Perfect. It works. And that is all there is. So if you have any questions, feel free to ask. Good luck on that homework.